Welcome to Troubleshooting Cloud Applications in the AI era. My name is Benji Soto. I am a product manager in Google Cloud. I run our AIOps portfolio, and I work on Gemini.
And my name is Preston Holmes. I'm also a product manager focused on Gemini for Google Cloud.
So today we're going to talk about a handful of topics. We'll talk about some challenges with observability, some key trends that we're seeing in the market. We'll tell you a little bit about what we're seeing that's making a difference now. And then we'll get hands-on with Gemini Cloud Assist. We'll talk about the near-term and long-term horizons. And we'll show you some demos, really cool ones. And we'll talk a bit about how traditional AIOps fits within this new world. So with that said, Preston, take us off with the observability challenges.
Great. So we're going to start about some of the challenge of today. And the truth is that the goals of monitoring and operating applications have remained pretty steady for quite a while. But the actual landscape of the challenges are constantly evolving. What you're managing, what you're operating has continued to change. And one of the big changes has been complexity, and that is, even if you consider the state of observability even 5 or 10 years ago, even if you left that technology in place, the systems on which you're observing have continued to increase in complexity. And so not only have those systems, the workloads really increased in complexity, but the tool chains have as well. These architectures have many more moving parts. They have many more layers. And these workloads continue to move to the cloud. And we often talk about this idea of hybrid IT in terms of hybrid infrastructure. But really, when you're talking about operations, sometimes you're also talking about hybrid applications, right? These are applications where part of the application workload is running on the cloud, part of it is running still in legacy or on-prem systems. And the observability solution really needs to encompass that entire landscape. Now, with more moving parts, you have many more components and layers in your application architectures. Each of these often have their own specialized sort of solutions or strategies around observability and troubleshooting. Many of these also increasingly involve a cloud component where there's a shared responsibility model. This idea of shared responsibility is a term that's been around for a long time, and cloud usually was introduced in the context of security, but shared responsibility also now applies to observability. So with all this increasing complexity, Benji, what are some of the impacts and challenges this poses on troubleshooting?
Sure. So observability providers are still catching up to these trends. And what you see out there is you see a lot of manual reactive investigations. There's lots of tools that have been picked up from the proliferation of all these observability tools. And you have data that's scattered in different sources. It's become a game of trial and error. So when there is an incident, there is an issue, you're generating a hypothesis. These teams are interacting in a Slack conversation, if you're using Slack. And it kind of gets a little bit intense. Everyone's trying to gather data and prove that they're not the source of the problem. And yes, I'm hearing some laughs because there's probably some, you relate to that. And what you also have is you have misinterpretation of that data. But what's really happened here is it's become really difficult to onboard your junior employees as well, right? And they're really impacted adversely because of this. They have to learn these tools, learn your data, pick up your context, and it's become difficult. Ultimately, troubleshooting is just expensive because of it, right? There's lots of hidden costs there. And some solutions out there have tried to solve this. Next slide. Which is really where traditional AIOps is kind of fit. Traditional AIOps is not new. It's existed for many years, and they have some common characteristics. There's a lot of data that's been gathered. You're proactively observing those events. You're looking for abnormalities, deviations, and you're looking across a bunch of different types of signals, metrics, logs, traces. And in best cases, if your data quality in your infrastructure has been set up correctly, there's service dependency data that you can try to traverse to understand the relationship between your IT system. But there's still lots of limitations. Because there's lots of tools, there's a lot of tech debt. You have to gather all that data together, and you have to try to co-locate it. And if you haven't managed data quality to the best part and implemented it within your process, it's really difficult to correlate because the data hasn't been labeled or joined in the right way from the start. And it's really difficult to prove that upfront to your team so that you reinforce that behavior. And you also have these an infinite amount of troubleshooting workflows, right? There's just so much out there. So when you try to automate, it's really difficult to pick and find what do you automate first, and then it's expensive to implement anyway. So automation of these workflows is difficult. And then you have lots of data, like massive data. And what that really leads to is, if you actually look at the existing challenges with that, is there's limited throughput, limited queries per second, and you need this data fast, because when you're troubleshooting, you don't necessarily know what you're looking for. You need to access that data, you need those insights to render a bit more proactively, and that becomes difficult when the throughput is a bit limited. Next slide. So what's different now? Preston?
Yeah, so as we've discussed, we're sort of at this point in time. We can recognize sort of 3 trends that have led us to this point. The first we've already covered, right? More and more workloads are moving to the cloud. But not only are the workloads moving to the cloud, but the observability tool chain itself is often more and more cloud hosted. And this has led to a couple things. First, it's greater consolidation around the tools used for observability, greater sort of conformance and conventions around the way the patterns are built around observability when things are cloud hosted. These cloud-based observability tools are also capable, because they're built on cloud storage systems, of retaining a lot more information for a lot longer, right? And this increase in the amount of observability data, since data is what powers the capability of AI solutions, is led to greater use of AI in this, in the observability space. But also, this volume of observability data is increasingly recognized as being valuable for the application itself, for the use case for which it was originally created. And these have set the stage for bringing in this current era of generative AI. And we can recognize sort of 4 kind of core areas. This isn't necessarily comprehensive, but first, and at the core of all of this, is the large language model, right? We've all recognized that large language models have unlocked this idea of being polyglot and allowing syntax conversions between natural language and specific type of query languages, whether they be SQL or other sort of DSLs more related to observability. It's the ability to augment these large language models with sort of just-in-time knowledge, so the same way we might consult recent tech notes or breaking release notes or other things that will bring us more current, we can bring that into the generative AI space. And this idea of retrieval for things like documents can apply to things that aren't as familiar to us, right? So you can use things like embedding to encode entire things such as like an incident itself, right? What is all the time series information that led up to an incident? These can be embedded and encoded in a way that make them available for the model to use in future events. And finally, as Benji's talked about, this idea of blending the AIOps sort of approach to large volumetric data with the LLMs unlock sort of new combinations at that intersection. So what we've announced at this conference is a new product called Gemini Cloud Assist. It actually focuses across a range of tasks in cloud sort of management operations and application lifecycle, including designing that application and optimizing it. Today we're here to focus on this sort of operate pillar, specifically how you can use some of the capabilities there for troubleshooting. So Benji, let's get more into the details of what the future of troubleshooting looks like and how it's realized.
Sure. So there's one consistent message that I'm hearing from my conversations with many of you, really. And that message is really that you can send all your observability data to Google Cloud, and Gemini will have access to it and be able to do something with it, which allows your teams to troubleshoot a bit quicker. That's just one message I'm hearing. And what that unlocks is really a co-collaborator on issues that your junior employees could interact with. You can find anything, anytime. You can enrich alert context with other resources or assets if you can find it semantically relevant. You can find insights pretty quickly. And you can automate workflows fast, right? These LLMs can actually run through instructions and do things. And then lastly, what this gives you is this really simplifies complexity and really brings you a new level of ease of use. And Google is taking the responsibility to try to build the system that'll unlock that value for you. So if we go to the next slide, this is a really overgeneralization of an implementation on what this could look like, right? So you have all of your telemetry storage solutions. You might be using Google Managed Prometheus or Google Cloud Logging or an open source solution. And then you have your observability sources as well, right? These are your dashboards, your alerts, maybe your IRM conversations, postmortems, troubleshooting guides. The list goes on, really, right? And then you have some of those key building block technologies, right? So that observability data is stored in vector storage, and what that really gives you is that really gives you dense vector representations known as embeddings, as Preston was mentioning. And what you can do with that is that you can do similarity calculations, right? So when a query comes into the model, whether it's from a user or a pre-canned prompt from the system, that query itself is translated into a vector representation within that text embedding model, allowing you to find relevant assets within vector storage, merging that with GCP context. This could be information that is stored within Google about your workloads, your events, your configurations, your resource states, right? And then there's some fancy prompt engineering there that does something and guides the model to interpret that data and provide some sort of insight or even take some sort of action. And really, that's the output that the model responds with, which is a response relevant to your context, right? So what we're going to do here is we're going to walk through some examples on how Google is trying to build this system so you can focus more time on reliability. So Preston, take us off.
Yeah, great. So obviously we can recognize that sort of AI space is extra frothy right now. I can only imagine how many times an hour you've been hearing at this conference those two letters, AI or generative AI. It's in kind of most talks and most booths. It's sort of everywhere. But we want to recognize that we are still relatively early in what is a journey, and that we can kind of break these down into sort of 4 levels or stages or layers here to sort of look at this as a progression. I'll briefly cover these because we're going to go through each of these. But the first is really something we've had out and in the product since we talked about Duet AI last year, which is really this idea of helping me understand and summarize the knowledge that is out there in a simple sort of summarization and help sort of shine the flashlight on what I need to be focused on. The second is really how do we bring this knowledge and augment it with real-time context around your environment. Level 3 is more around how do we take that enhanced contextualized information and actually walk you through a process or a procedure to continue to troubleshoot. And then layer 4 is sort of our North Star, right? This is where we take our hands off the wheel. This is much more fully autonomous, longer-term delegation of some of the work. So starting with level 1, this is really this idea of something I think we've now kind of become familiar, which is the LLM-powered chatbot that has been trained on all of the internet's information and can help focus what part of that vast amount of knowledge I need for my particular question at the time I'm trying to do something. And while this is not really considered the bleeding edge of LLM sort of capabilities anymore, it continues to be one of the things that's genuinely useful when you're trying to operate the cloud, right? We've all poured through large amounts of docs and web pages. And to give you an example of how we would use this in troubleshooting is, I might ask a question about like, how would I troubleshoot a crash looping pod? Now I can go off and type that into a Google search, and then I can go and read 5 or 6 maybe blog posts and articles, but if I want that context in the place where I'm actually doing the troubleshooting of my application in the console, I can get a nice succinct summary. Or if it's even more GCP specific, I might ask about what might be some approaches and practices I can use to troubleshoot latency in my applications. Now we can take that idea of general knowledge and continue to sort of focus it by passing the model more information about, say, a specific log entry that you're currently looking at. And here the idea is that we want the context of your answer to include not everything it knows, say, about a particular Java stack trace, but what are the particular details that are available in your log entry. And actually, we've enhanced this and we'll be releasing an improvement to this where we've asked the model to think a little bit more, not just to explain it, but then to suggest some potential troubleshooting steps. So this idea of pulling more context just in time into the model is really our bridge to layer 2. So Benji, why don't you tell us more about what layer 2 can do for us?
Sure thing. So L1 is what Preston just talked about, and that's available now in production. L2 is what's coming next. The focus of L2 is really about information retrieval. So really, in a nutshell, if there's an API out there that can go ahead and access information and provide that output, LLMs can do that as well. This could be your performance metrics. This could be resource metadata. This could be billing and cost data. Really, any information that exists out there can be accessed by an LLM and provided to whoever is querying that information. So let's look at one example. So I don't know if any of you love building queries. I certainly don't. I don't know anybody who was born knowing how to write these queries, but queries are a bit unnatural. So in this example, you're able to query your monitoring performance data. And in this case, we were looking at a backend latency metric, just using English and being able to provide that data back. So, what this allows you to do is really not have to sit there and think about how to translate the question you have into a query language that is unnatural to you, and then run it to retrieve that data back. So Gemini can do it for you, really. But it doesn't stop with monitoring data. In this example, it's with PromQL, but you can do this with SQL or any other query language that exists out there to access your metrics, your logs, your traces, cost data, and the list really goes on, right? So wouldn't we all want to live in a world where you don't have to build any more queries? Next slide. So the next one is around querying resources. So you have lots of alerts, dashboards, you have playbooks. There's many resources that exist out there, however you define your resources, that you use within observability for troubleshooting. And the key here is that there are resources you care most about. And those are the ones you probably have hot links for, favorites, right? But there's lots of resources you don't care about. For example, the ones that exist with other teams. You really don't care about their alerts, their dashboards as much, unless maybe they are a dependent service to you. In that situation, you can use Gemini to access the resources you're not familiar with really quickly. So in this example, you can see that we're asking Gemini about alerting information that may or may not exist within our system, but with another team. So catch me up on alerts, and Gemini is able to respond with the previous alerting information. So this ease of use is what's going to lead to a change in behaviors. And that behavior is going to probably start to evolve the troubleshooting journey a bit more. And what that basically means is a bit more of a shift left mentality. So if we go to the next slide, we recently offered mobile app support, or mobile app PMs right over there. Hello, Camille. And mobile app support for these Gemini experiences. And as the ease of use improves, what you're going to see is I guess what you're going to be able to do is you're going to be able to troubleshoot on your phone before escalating to your laptop when there is an incident, right? I'm sure we've all been there where you're on call, there's a notification that comes in, maybe you're at the doctor's appointment, and you need to respond to this alert, but you don't know what's the sense of priority. You're going to be able to probe that information a bit more by working with Gemini to access your information, troubleshoot that, and provide that information back so that way you know whether or not you need to dive in deeper, tag in another team member, or take another action. So what that basically means is, you're going to be able to troubleshoot on your mobile phone, which is something you've never seen before. Troubleshooting tools troubleshooting tools are normally built for web apps, right? They're not really built for mobile apps. And all of this is really going to lead us to what is transitioning us to the L3 capabilities, which is a bit more focused on automation. Preston?
Great. Yeah, so if layer 2 is really around bringing in this kind of just-in-time, real-time information into the sort of troubleshooting space, layer 3 is really about how do we then introduce and create new data, new information that wasn't already pre-existing as part of a process or procedure. Right, so this is really about bringing AI and taking action in the troubleshooting flow. So this might be informed by playbooks and sort of diagnostics. All of this is really in that quest to get down to the root cause that has you troubleshooting something in the first place. For example, Benji, how would I ask Cloud Assist to help if my app seems to be running slow?
Sure. So let's go ahead and ask Gemini. So in this example, we're not running a demo. Let's
see if it'll play.
Let's see real quick. We're going to try to get this demo to run. It's a GIF. So I'll just talk through it. So what happens here is if you were to ask Gemini to run a latency test, Gemini is able to look amongst all the playbooks that we've fed it. And these playbooks might be a set of instructions on what to go do when you're seeing a certain type of signal or a certain type of issue, and what steps you need to take to validate that root cause and pull a bit more information back. Gemini is actually able to find that playbook, run a latency test, and then provide some responses back. So in this top right-hand corner, you're able to see that Gemini actually ran a latency test and identified that there was an overload of latency in a certain region and provided some insights that basically tell you a bit more of what's going on with the latency within your service. Go to the next slide.
So yeah, I think I realized what happened. When we ran through our slides, we pre-played all the GIFs, and then we went back to the beginning, and they've already played through. So let's just say that connectivity isn't something that you just need to investigate in a production incident, right? Connectivity is something, even when setting up an application, you might need to understand, hey, why can't I reach from system A, system B? What's going on? Right, so with Gemini, what you can actually do is, hey, help me troubleshoot a connection to this particular system. And if you run that connectivity test, Gemini will actually use a tool, do the probe, et cetera, and it can actually even do things like find the firewall rule that might have been introduced into that environment to cause that kind of outage.
We got it going.
All right, so I'm having connectivity issues, reaching load balancer. Here we go. It will even prompt me for sort of follow-up questions like, wait, where do you want to actually test this from? In this case, since I'm doing development from an on-prem client, I can put in an IP address. It will try to reach the service from that sort of subnet, and then realize that the system I'm trying to hit is unreachable, and this is why, right? And so this is something that I could have spent a lot of time setting up a test VM to run a ping or a trace route from, and would have taken me a bunch of time to kind of set up my own testing, and Gemini's done it for me. Ready to fly blind?
Just run it. So it doesn't stop there. I think everyone's been in that situation where you're messing around with an app, maybe it's on your phone. In this situation, we're looking at the console, and you see an error. And you're not familiar what that error is, what it represents, what it does. I mean, these are managed services after all. You didn't really build them. You can actually take an error that you find in the console, send it over to Gemini. Gemini will look through its library of playbooks and provide you with either insights or recommendation to try that playbook out yourself. So these are contextually relevant suggestions that are essentially embedded directly within the console. But we're not done there. So these are some L2, L3 capabilities. What else is there, Preston?
And these are what we're trying to bring to you now in the next coming months with Gemini Cloud Assist. But we recognize that there's sort of this North Star idea. This is sort of the future state, right? This is going to involve a lot more trust in delegating longer running tasks or more autonomy to these sorts of agents. And it's really about evolving this from assistant to associate, right? Right now, this is very much interactive, your co-collaborator and troubleshooting. Someday we can imagine leading to sort of a more trusted delegation model. And part of what might get us there, it's been interesting working with these sort of LLM-based products over the last year, is that a lot of the features that we are demonstrating to you today were not programmed by our software engineers, right? The capabilities that LLMs unlock as features were emergent and the result of the large training process of these models. And so that means that the innovation is somewhat now decoupled from the traditional approach of writing a list of feature backlog requests and planning to do X, Y, or Z. A lot of what will be coming from this kind of technology is a bit unpredictable and will emerge as the models become more capable on their own of doing new things. And so that's what's going to make this a pretty exciting and turbulent next couple years. So, but for now, we're still in 2024. We're sitting on these sort of mountains of AIOps-oriented data. What can we do now that we've got this sort of combination of LLM and AIOps, Benji?
Yeah, I think what you're going to see is these cloud assist capabilities are we're going to test them, we're going to fall short sometimes, we're going to fix them, we're going to update them, and then we're going to kind of iterate through that. But what's going to happen is it's going to merge with your existing tooling. And that's where it has to, because that's what's happening today. If you use an AIOps solution today, what we're going to see is Cloud Assist merging with those AIOps capabilities, and what AIOps offers versus what these Gemini LLM capability offers are actually very complementary, right? On the left-hand side, you have an AIOps solution that can do proactive analysis, anomaly detection, look at correlated trends. And you have another system over here that's, can actually automate a bunch of workflows and run through maybe deterministic or procedural steps to basically execute a series of actions, access your information, and interpret those insights. But when you bring those together, you really unlock a new kind of an observability product that really hasn't existed yet, right? So it's super exciting. So what I'm going to show you today is an example of an AIOps solution that starts to add a little bit of LLMs, right? Now, it's not fully there because it's going to take some time. But this is something that we're going to be launching to preview over the next couple months as well. So let's jump into this one. This is a full video. So let's go ahead and hit play. Pause it there for a second. So we're in the Google Cloud Console. We're looking at an alert. An alert just triggered. You can see that this alert was triggered on server errors. And at the very top, you can see that there's this new banner. The banner is essentially offering you insights through Gemini Cloud Assist. So let's go ahead and click that banner real quick. So we navigate over, hit investigate, and the page is going to load. Let's pause it there. And what you can see here is that based off of this alert, Google was able to identify what other services are impacted. In this case, we're looking at a GKE service. This is an e-commerce application. It's a microservice architecture. The alert was triggered on the front-end service, but there's 3 other services that are also impacted. The alert triggered on the front-end service, and then Google actually thinks that you should go look at the payment service, right? And on the top right-hand corner, you can see that there's an investigation period. Let's hit play. And what's actually happening here is Google is looking at your historical data and then looking at the data triggered within this alert time frame to essentially analyze your service dependencies and see what else is acting abnormal. So let's pause it right here for a quick second. So what you see is you see an affected topology, right? The front-end service is communicating with a multitude of other services. There's the currency service, the cart service, et cetera. You can see that the checkout service is also impacted. And essentially, you could start to see where the problem is coming from. Let's hit play. And we're able to do that because with this given alert, we have service dependency data. You know the source and destination between the different components within this service architecture. And when we hit the checkout service, you can actually see that the payment service is also affected. It's a couple hops away. So let's hit play again. Now, the table gives you the evidence. You can see that there's error rates, latency. These are essentially the golden signals that are acting anomalistic. Let's pause it right over here. And below that, now that we've selected the suspected service, which is the payment service, you can see the evidence. The evidence shows that there's request by operations, which is bouncing a bit. You can see the P50 latency, which started to spike around 7:15 p.m. And then in the top right-hand corner, you can see the error rate, which also spiked. But there's something else. There's this annotation. And when you hover over that annotation, you can see that a GKE deployment happened around that time frame as well. So you can actually click that GKE deployment. It'll take you directly to that log. That log is going to tell you who made the deployment, some information about that deployment. You might go ahead and ping the person who made that deployment. And then we go ahead and transition over to the logs. Let's pause here. The logs is essentially log pattern analysis. The histogram here shows you that there wasn't any of these log entries that were triggered prior to 7:15, so it's a new log entry. And it looks like the log entry has to do with payment service errors, so something's wrong with the payment gateway. These are net new logs that we haven't seen before. And through Gemini, we were able to explain that log to provide a little bit more information about what that log represents and what you might be able to go do with that. Now, this is just an example of one of our first iterations of a native, out-of-the-box AIOps solution that comes with Google Cloud Observability. But if you can see and merge this with the other capabilities that we are experimenting with on Gemini Cloud Assist, being able to find a playbook, being able to access your information, being able to run that playbook and provide those results, and merge that with an AIOps solution that is a bit more proactive with anomaly detection. This is a new kind of an observability product that doesn't exist yet, right? So you can start to see the vision and where that's heading. So with that said, let's go to the next slide. Overall, right, what you're seeing is there's lots of innovation coming to observability. It's a new kind of observability AI, and you're going to see that merge with traditional AIOps and build on top of what's been done in that space as well.
In addition to that, some of this idea of going to this layer 3, bringing in automation workflows, finding and sort of guiding you through playbooks and diagnostics. We're really about sort of bringing that live context to the troubleshooting flow. And finally, this idea of the autopilot vision, right? I think while it will take some time, this is all about increasing both the capabilities and the trust over time until we can maybe kind of take our hands a little bit off the wheel some of the time. Now, a lot of this is brand new. This is a journey that we are on, that we want to go on with you. So we're very interested in folks who are interested in being early adopters of this technology, interested in your input, and areas around how we can just improve the reliability overall for everyone, really. So Benji?
So with that said, if you are interested in talking to one of our team members and providing feedback during the conference, you can actually take a picture of that QR code. If you want to talk to us after the conference when you get home, relax, and rest, you can take a picture of that QR code. So everybody take out your phones if you're interested in talking to our teams and getting involved with the Gemini Cloud Assist. We're more than happy to hear what are your use cases, where do we fall short, and how can we iterate on our product direction.